All right, so here's kind of a mix and match of everything. Got some names, got some formulas, got some anions, and we're going to have to kind of put the pieces of the puzzle together. And there's some things that you got to keep in mind, so we'll highlight some important things as we go through this. All right, to start with, magnesium oxide, nice and easy. No Roman numerals, no polyatomic ions, it's just plain old magnesium. You look on the periodic table, it's in group 2, so it makes +2 charge. Oxide is normal old oxygen. Magnesium says here, take 2 electrons. Oxygen says that's perfect, I need 2. They hook up on a 1-to-1 ratio. Notice I didn't write the 2's. The 2 and the 2 are opposite but equal. +2, -2, so they cancel out, it's just MgO. Now here's aluminum trying to give away 3 electrons, and little chlorine says, I can only take 1, but I'll find some friends. So we crisscross. We take the 3, put it after the chlorine, and then take the 1, the imaginary 1, put it after the aluminum, which we don't really write. So it's AlCl3, and then I write the name. It's aluminum chloride. Notice it's an "ide" ending because chlorine is right off the periodic table. It's not a polyatomic ion. And I don't use Roman numerals because aluminum is not one of those elements that makes more than 1 charge. But lead is. The only way you know that is refer back to that chart. Lead is a low p block element. I actually want to write L here. So there's a potential for it to make more than 1 charge, so you have to look up on your list and you see that lead does. So we don't know which one it is. It could be a +2 or it could be a +4. We're not sure which Roman numeral to put in here yet. But we do know it's hooking up with sulfur, which is just normal old sulfur on the periodic table, so it's sulfide in the name. It's not sulfate. It's not oxygen bonded to it. It's not a polyatomic. It's just normal old sulfur, which turns into sulfide. So let's uncrisscross this here. We've got lead with an imaginary 1, sulfur with imaginary 1. So if we were to uncrisscross this, this is what we would get. Sulfur with a -1 and lead with a +1. This isn't right. You look on the periodic table and sulfur is in group 6. It needs 2 to get to 8, not 1. So we're going to double everything. We're going to make this a -2. This becomes a +2. So it's a Pb +2, S -2. That's correct, so therefore this must be correct. So lead is a +2 charge in this case. All right, chromium 3 bromide. I love seeing Roman numerals. That tells me chromium's +3. I don't even need to think, as long as I know the formula or the symbol for chromium, it's Cr. Bromine, I have to look on the periodic table. It's in group 7. It needs 1 more to get to 8. So chromium says here, take 3 electrons. Bromine says, I can only take 1, but I'll find some friends. So we crisscross the charges. 3 goes here, 1 goes there. So it's Cr with imaginary 1, Br3. Chromium 3 bromide. All right, so I look on the periodic table and I find iron is in the D block. So I think to myself, it might make more than 1 charge. Let me look it up. Oops. So I look up in my list and I realize that, yeah, iron could make a +2 or a +3. Not sure which one until I look over here, and that gives it away. So iron 3, and then SO4 is not plain old sulfide, it's sulfate. So SO4 sulfate. So crisscross them. Put the 3 there and the 2 there. It's Fe2. Now I'm going to have to write a 3 after the sulfate. So I want to isolate sulfate and make sure I have 3 sets of that. So I put a 3 in parentheses. So iron sulfate. All right, sodium. Normal old sodium on the periodic table, +1. Phosphate, 8. Tells me it's P with some oxygens there. How many? I don't know until I look them up or memorize them. But PO4 with a -3 charge, that's what should be in your brain by now. Crisscross the charges. It's Na3PO4. Notice no Roman numerals because I didn't write a number after phosphate. So I'm sorry, no parentheses, silly. I didn't write a number after the phosphate, so I don't need parentheses at all. Over here, tin and nitrogen bonding together. I look on the periodic table and I see nitrogen's in group 5. It needs to get to 8, so it's going to gain 3. And then I uncrisscross the tin, because remember tin could make a +2 or a +4. I don't know which is which. until I uncrisscross them. So that 4 goes up there, so it's plus 4. So I write the Roman numeral for 4 there. Now here I see iron 3. Again, I love Roman numerals because I don't have to think. Iron makes a plus 3 charge. Oxygen always makes a 2. I crisscross my charges. 3 goes there, 2 goes there. Fe2O3, iron 3 oxide. Over here, iron's making a plus 2. Gotta love Roman numerals. Plus 2, negative 2, that's a 1-to-1 ratio. Iron says take 2. Oxygen says that's perfect, I need 2. And they make a 1-to-1 ratio. Don't write the little 2's down here. 1-to-1. Copper plus 2, chlorine's negative 1. Crisscross your charges. So we end up with Cu, imaginary 1, Cl2. Now, if I just wrote copper chloride, if I just write copper chloride, I have a problem because I don't know which copper it is. Because copper can make a plus 1 or a plus 2. The only way I know that is I recognize that it's in the D block, and then I look it up on my list and I realize, oh, copper's one of those guys that makes more than one charge. So which one does it make? Roman numeral tells me, or the charge tells me it's a Roman numeral 2. So I put a 2 there. I look right away and I can tell without even looking on the periodic table that mercury can make more than one charge because it hooks up in different ratios with oxygen. So mercury, I look on the periodic table, can make plus 1 or plus 2. I don't know which is which until I uncrisscross them. And it's going to hook up with oxygen, so it's oxide. So uncrisscross, 1 and 1. So right now I have Hg plus 1, which is feasible, but oxygen negative 1? Oxygen doesn't make a negative 1. Oxygen's a group 6. It needs to go up to 8. It needs to get 2. So this is wrong. So I got to double everything. Multiply everything by 2. That goes for the mercury and the oxygen. So Hg is not a plus 1, it's a plus 2. So in this case, Roman numeral 2. Over here, I see that if I uncrisscross it, let me do some blue, the 2 goes after the oxygen. So oxygen is going to be a negative 2. That's correct. So that imaginary 1 can go after the mercury. Hg plus 1. Roman numeral 1. All right, nice and simple one. Magnesium, I look on the periodic table, it's plus 2. Chlorine, I look on the periodic table, it's negative 1. Magnesium says take 2. Chlorine says I can't. I can only take 1, but I'll find a friend. So we have magnesium chloride right from the periodic table. So it's an "-ide" ending, nothing fancy here. Nickel 2, there's those Roman numerals that are awesome. I don't even need to look it up. Nickel makes a plus 2. Iodine is in group 7, and it's going to gain 1 to be 8. So it's a negative 1. Nickel says take 2. Iodine says I can't. I can only take 1, but I'll find a friend. Crisscross your charges, and it's nickel iodide with I2. PbO2. So here we go. Lead is one of those low P's. It could make more than one charge. In fact, it can make a plus 2 or a plus 4. How do you know this? You got to look it up on your reference sheet there. It's hooking up with oxygen, so it's oxide. Now, oxygen always makes a negative 2. But if I uncrisscross this, watch what happens. That imaginary 1 ends up on top of oxygen. Oxygen doesn't make a negative 1. Then lead, Pb, would make a plus 2. That's not right. If I uncrisscross this, I don't like the results. So I've got to double everything to make oxygen correct, because I know oxygen always makes a negative 2. So that becomes Pb plus 4. That becomes negative 2. So it's lead 4. The lead 4 is the right charge. All right, lithium nitride. Lithium's right on the periodic table, group 1. Nitrogen, I tells you it's normal nitrogen off the periodic table. It's in group 5. It's got to get up to 8 electrons, so it gains 3 more. Crisscross your charges. So it's Li3N, lithium nitride. All right, now I got some calcium trying to give away 2 electrons. Little nitrate, my package here, can only take 1 because of its charge. So nitrate goes and finds a friend. So the 2 is going to go after the nitrate. The 1's going to go after the calcium. Calcium, imaginary 1. Now I'm going to put a 2. Here's my nitrate. I'm going to put a 2 after my nitrate. The whole nitrate goes in parentheses. Calcium nitrate. Fen. This is a 1-to-1 ratio, but if I uncrisscross it, This is not right. Fe doesn't make a +1. Iron is one of those guys that can make more than one charge. It can make a 2 or a 3. So this isn't right. On top of it, when I look at my anion, which is most important in determining if it's right or not, nitrogen doesn't make a -1. Nitrogen's in group 5. It needs to go up to 8, so it needs to get 3. So I got to triple this whole thing. So if I triple my iron, it's going to be Fe +3, which is one of my options. And if I triple my nitrogen, then it's correct. So Fe +3 and -3, that's a 1-to-1 ratio, which is why it's written with no subscripts. Now this is just normal old nitrogen off the periodic table, so it's nitride. Love them. Pb +2. Hydroxide, yeah, it ends in "ide", but don't go looking on the periodic table because you won't find it. It should be in your brain by now. That's hydroxide. Crisscross the charges. Pb, now watch this. I'm going to put the 2 after the hydroxide. I have to put the polyatomic ion in parentheses. Even though there's no little subscripts in the polyatomic, it's still OH, it's still a polyatomic, it still needs to go in parentheses. Finally, Sn +4, sulfate is -2. If I crisscross it, watch what happens. I end up with a 2 over here and a 4 over here. This can be reduced. So it's SN1, imaginary 1, and then SO4, and I'm going to write a 2 after it, so the SO4 has to go in parentheses. So this is tin, and tin had a +4 charge. Sulfate. Now how did I know? ATE. How did I know that this needs Roman numerals? I look at my reference sheet. I realize tin is a low P element. It's in the P block. It's a low P block element. So there's a potential for it to have more than one charge. So I look at my reference sheet and I see that tin can make a +2 or +4. You'll always have a reference sheet to look at, but make sure you look at it. So in this case, it's a +4.